Hello, students. Mr. Murphy back here again, and we're doing lesson 9, scientific notation. Now, just think for a second. Last lesson we did magnitude. So if we had a really big number like 935 billion, 4,070,812. And if we want to get a magnitude that was close to this, we would round it up to the next 10. And so we put a 0 with all of these, right? And we count them up. So we got 3, 6, 9, 10, 11, 12. So that would be we do about like this, about 10 to the 12th magnitude, okay? Scientific notation is going to be a little bit more accurate. So instead of rounding up to the nearest 10, we're going to move the decimal point. So there's a hidden decimal point here. We're going to move it to here, just between the 9 and the 3. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to move 11 spots. So that would be times 10 to the 11th. And then we're just going to take the first number or two, 9.35. Now we can go 9.35, 004, 007, 00812, but that's not saving us anything. Usually scientific notation is 1 or 2 decimal points, okay? But here's the important thing. So scientific notation is a number times 10 to the nth. So we got our 10 to the nth power, we got our magnitude, and we got the number from the first couple of numbers here. But it always has to be 1 digit in front of the decimal place. That means this is saying right here, that number, D, has to be between 1 and 10. So we got 1 digit between the decimal places. Then it's scientific notation, right? So let's see how that works in real life. Which one of these are scientific notation? 1.908 times 10 to the 17. So this is between 1 and 10. So yes, this is scientific notation. 0.325 times 10 to the second, negative 2? No, because this is a 0. It's less than 1. So this is a no. What about this one? 7.99 times 10 to the 12th? Well, 7.99 is between 1 and 10. So this is a yes. And what about this one? 4.0701 plus 10 to the 7th. Well, we're adding here, and we're supposed to multiply. So this is a big no. 18.432 times 5. Well, 18 is not between 1 and 10. And we're not doing powers of 5, we're doing powers of 10. So this is a no. And what about 8 times 10 to the negative 11? Yes, that works, because this is between 1 and 10, and this is a power of 10. Yes, it's a small number, but it's still a power of 10. So this one would be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be this decimal. Okay. All right, let's try and add some big numbers. So these are the debts for these cities or states. California is $407 trillion in debt. New York is $337 trillion in debt, and Texas is $276 trillion in debt. So let's add them up. If we want to add them up, I can just add these numbers and put all these zeros, but I'm going to put them in scientific notation to make it easier so I don't have to write all of that. So this is 4.07 times 10, and what do we got? 3, 6, 9, 10, 11. 4.07 to the 11th power. This is 3.37 times 10 to the 11th power. I know it's the 11th power because it's the same number of zeros. So this one would be 2.76 times 10 to the 11th power. So if I'm going to add these up, These are still going to be 10 to the 11th power. And this, I add them up. So 7 and 7 is 14, plus 6 is 20. And 2 plus 3 plus 7, so that's 12. And 4, 5, 6, 7, 8, 9, 10. 10.20 times 10 to the 11th. But it's not in scientific notation anymore. I've got to move this one spot to the left. And if I move that one spot to the left, this is going to go up to 12. So the answer would be 1.02 times 10 to the 12th power. I can drop this 0 because it's not necessary. Right? So that's adding large numbers. I can do all of those, but we're going to move on and just, I think we'll stop right there for now.